Start with RBD then. Go ahead.
Okay. So the first one I had on the list was trying to delineate out some RBAC style cap controls for RBD. We have, I think, starting the Luminous release, we added profile RBD and profile RBD read only. That just kind of give you generic read-write access or read-only access to a pool, do RBD-like things in a pool. But there has been a request to say, can we do something, more granular, like, and break up roles where you have like a storage admin who has the rights to create, delete, resize, or whatever images, and you just have a standard user that just has the ability to read and write to images, not to restrict them down to you have access to image ABC, but to say you only have access to read and write to images. We have the namespace support that's being added for Nautilus that will kind of at least provide tenant level isolation between images within a pool to try to solve that one use case of, making sure that people can only access the images that they should have access to without having to use Ceph to say, well, if it starts with this specific image ID, things like that.
The party wasn't sure about is this orthogonal to the namespaces? Like we would add this.
Yeah, this wouldn't depend on namespaces. This would just be namespaces is half in right now. The issue or the portions that are not in with namespaces is the ability to clone across namespaces, so you can copy and import across namespaces and things like that. So it seems like we always try to push cloning as the better option to copy, and so it seems like you should also be able to clone across namespaces. I've got that code about halfway done, and then there's the other big section is the RBD mirroring support for namespaces.
Okay.
So yeah, this would just be something that you could use anywhere, and just say, well, we can create some new profiles that our profile allow ABC, and we can restrict what class methods you're allowed to touch, or if you're allowed to execute any class methods. For just reading and writing images, I mean, there's a couple class methods that, the getter method, so you can do like class read operations, but you're not allowed to do any class write operations to manipulate the images. So it should be pretty straightforward.
I'm just wondering if it's gonna combine with the namespaces, so you can say I want to use the read only mode or whatever, or like read write but not delete mode in a particular namespace. Will they?
Oh yeah, I got what you're saying. Yeah, as part of namespace, I think the namespace in the caps is already there. It's like left over. It was there for Ceph. I haven't tested it yet, but I was hoping it's already there. So you should be able to tag right on top of it, because you could already say like profile RBD pool XYZ. It should be also namespace ABC.
Okay.
I see no reason not to allow that. It's the broader question to it is, do we want to keep adding all these things to, these magical profiles to the monitor, the OSD cap, class where it, can decipher all these, or do we want a more generic solution? Not necessarily for Nautilus, but like plan forward, where you can define arbitrary cap profiles and not hard code them into the code. Obviously, in the short term, hard coding them into the code is a lot easier. I just feel.
Yeah, that's a good question.
I feel like RBD is going to start taking advantage of it, right? Because we're the only ones that, there's the bootstrap stuff for profiles, and now in Luminous we added profile RBD and profile RBD read only, and I don't see us adding like 20 new RBAC low level RBAC profiles, but if you had something where you could just generically say like Ceph auth profile, get or set, and
so there's
change it on the fly, or define.
There's sort of a similar thing that we want to do also for Nautilus, which is actually to have an explicit role. So you define like a Cephx auth entry that's like client.role.foo that defines certain set of caps, and then you could map a user to that role. This is what the Kerberos stuff. So that based on if you're in a Kerberos group for Ceph admins or something, you get mapped. You end up inheriting the caps of that particular role definition.
So if
I don't know if that's
so if that's
exactly the
going,
same thing, though.
so how's the role going to define the caps?
Well, that's TBD. There'll be
Okay.
some magic that happens in the monitor when you authenticate that says, oh, there's something about this user authenticating that makes me want to check what roles would apply to them, and there'll be some rules around that. And
Okay.
then assuming that matches, in the Kerberos case, it'll be based on like what group they're in the Kerberos domain.
Yeah.
Then we'll map it to a.
I mean, is that
We'll
like something
basically
where you're
just
trying
take
to
all
pull
the
it out of
caps
like
for that role and add them
you're trying to pull it out like the roll out of LDAP or something like that, or
in. Yeah, or something like that.
or
Yeah,
okay.
it could be old app. It could be the host them group if it's already expressed on the machine, or it could be the MS pack thing, the
Okay.
proprietary weird active directory, whatever. But either way, there'll be some way to map a user to a role.
Yeah.
But I'm not sure that that's quite the same thing because it feels to me like this is a little bit parameterized. Like you want to say, I want the read-only caps for this namespace. So it's really
Well,
shorthand for like a specific set of.
well, but it is user roles, right? Like the storage admins have the
Yeah,
role to
yeah,
create and delete and modify images, and storage users
don't,
just have the
right?
role to
Yeah, I guess.
read
Yeah,
and write images.
yep, yep. It seems like there's sort of two orthogonal pieces. One is that we want to be able to like map roles to caps without having to redefine them every time. And the other
Yeah.
is we want to have like a canonical correct um, specification of what that role is supposed to do and that
Mhm.
we are maintaining because otherwise users are going to get it wrong or they'll follow
Yeah.
documentation get it wrong.
So you think
So
you think at least going forward for short-term profiles, just
I
defining the
would keep
code
going.
and okay, that
That,
sounds good.
yeah,
It certainly
that'd be
makes
my
the upgrade
suggestion.
case easier if we ever find like a bug or want to expand it. It
Exactly
just
right.
happens, and there's no upgrade steps to say
Right.
we
Exactly.
don't
Yeah.
get the we don't get the monthly like mailing list issue about like why am I getting IO errors on my RBD images? Did you follow step
Right.
6 on a voluminous upgrade guide? Like,
Exactly. Yeah. Yep.
all right, I'm fine with that.
Okay.
That's really all I had on that one. All these should be really short topics.
Cool. All right.
Okay.
Quotas and provision quotas.
So yeah, bin provision quotas. Again, this is a request to say, as a storage admin, I want to basically set up this namespace or, only is allowed to provision out, X amount of space for all images within that namespace or within that pool if you're not using, namespaces. And it's bin provision quotas, so it wouldn't necessarily track the actual usage of the image. So really all we have to do is track in the RBD directory or whatever, when we create an image, we can track the size of the image. We need to put it in one spot because we don't want to have to open up 30 or 10,000 images to figure out the current provision space. The RBD directory seems like a natural place to put it. The one thing we are going to have to do is we're going to have to tag those images or that pool to say, you need to have a client version greater than or equal to Nautilus if you're using this feature. Otherwise, it wouldn't know to actually update the metadata correctly. We can do that using we can do that using the existing min client version, but that's kind of heavy-handed. With Mimic, we added within RBDs we added this feature called the op feature code, which basically you can read and write to the images all you want, but you can't do any manipulation of it if your client doesn't understand one of these ops feature codes. So we can add if you're in one of these pools or namespaces where a storage admin is defined a bin provision quota, we can have the at least the newer clients can, when they create the image, they would properly tag it, saying like older clients can't open it and manipulate it and resize it or whatever or delete it. But it doesn't stop the case of older clients creating images and not actually setting the proper fields. But if you're using namespaces only, you have to have a newer client anyway to use namespaces.
Yeah. Okay.
So
Yeah, maybe just mirroring it to namespaces.
Yeah, I mean, if you set a quota in namespaces, you by definition have to have a Nautilus or later client, which would, by definition also understand these provision quotas, and there's no worries. And then we can use the op feature code to restrict older clients from doing things like removing or resizing or whatever.
Okay. And you can probably have a command that will just actually will iterate over the directory and get the size of every item and make sure the directory is up to date. But you knew you'd do that at the beginning, enabling the feature anyway, and you could run that.
Yeah. So like actually like
check.
Initialize it initially. We can do that.
Or to scrub later if you're concerned that something got out of sync.
Audit. Yeah.
Okay.
That's fair enough.
Cool. Okay.
That's all I had on that. Next one is the RBD mirroring remote cluster key management. So this came out of talks with John and the whole like orchestration about how to provision the RBD mirror daemon. So right now, when we provision out the RBD mirror daemon, we kind of expect and require you have to have the remote cluster.conf, ceph.conf file wherever RBD mirror daemon is located, and that's how. When you set up that remote cluster, the name of that remote cluster is the name of the configuration file it goes and tries to open on the client side, which is fine and dandy until we start getting containers involved in automation and things like that, like have to inject the ceph.conf file for a remote cluster is kind of awkward and hard. So what we can do, we can store the mon addresses instead of the cluster name. And we already store the user ID to use. So the only piece of data that we wouldn't have then is the key. So then I was thinking, well, we could just, there's already the config key stuff in the monitor. It has it's already being used right now for the crypt keys, the encrypt keys, and things like that. We could just create a key in there that is, here's the key to use for that user to talk to that other cluster for RBD mirroring. And that's something that, Ceph dashboard can inject that data in. The RBD CLI can be modified to inject that data in. We just have to have some way to properly protect that data so that the standard user just can't read, all the config keys. And I'm not even sure we do that correctly right now for the dencrypt stuff.
Yeah.
If you just have, I think if you have allow R, R on the monitor, it gives you full access to dump everything.
The config key data. Yeah, we have to check that. The other option would be to put it in the auth database and call it, client.uuid.admin or whatever, something like that. You could stick it there.
But can a regular client actually get that data out, or they would have to have the high enough permission, like RBD mirror daemon have to have high enough permission to dump out for something named auth XYZ.
Yeah, exactly. So config key is probably a better place to put it and then correctly lock it down. So I guess the to-do item is to figure out what the current behavior is and make sure it's restricted. And then second, we can you can set up caps that restrict access to subsets of the config key namespace.
Can you do that where you basically just like globally like blacklist a section of the config key and then you explicitly enable it? Or
you can't blacklist. You can it's always additive. So we just have to make sure that allow R doesn't give you anything.
In config key, okay.
Right, and then you do allow config key prefix.
Yeah.
Whatever.
That's actually I got. It was just a bigger question of the way to properly lock down the config key because there's other secrets we're putting in there, I think, and so I think now we have the Rados gateway stuff in there for dashboard and.
Yeah, that's that because if it's not locked down, we need to fix that quickly. I feel like this has come up before, but I don't remember what it does. Okay.
Yeah, that was my plan. It's just the question about how to properly secure the config key stuff.
Okay. Would all the other metadata about the remote cluster also go in config key? Like the
only thing I was really the only thing, Monhost can go in there, but I was really thinking I've already got a data structure on this that's already describing the peer that has the the client ID. I can quickly add just a
Okay.
a JSON field or whatever array, buffer list in there
Yeah.
to store them on addresses. It was just I didn't want to also store
Yeah. Yeah.
off data because I wanted to be
Yeah.
able to lock it down.
Is it like a single place that has the metadata about the remote cluster, or is there like a copy of it in every
There's
image?
in each pool there'd be an RBD underscore mirroring object that has all the metadata associated with mirroring.
Okay. Okay.
If you have read access to that pool, you would just be able to do what you would need to be able to have in order to get like RBD mirror stats and things like that. You would be able to dump the key, and that's why they want to store it there.
Yep. Okay. I think that sounds fine.
Okay.
Um,
And the last on my list, I don't see. I think Nicole is also on vacation this week.
yeah.
But he wanted to start tackling the pool level configuration overrides for RBD mirror. Right now, we have some trickery. We already have image level RBD mirror overrides, and you can do with Luminous or Mimic when you added all the global config overrides. You can override things without having to put it on like 1,000 hypervisors like Ceph.conf file. So now the question is, well, what if we want like pool level defaults? We can dummy something up ourselves and like throw an object in the pool and here's all the config overrides. But the question is would it be more valuable to somehow do something generically in the Ceph config world to allow?
Yeah. Hmm.
So are these specifically RBD config settings, or would this be like stuff that affected things on a per PG basis on the OSD as well, potentially?
So that was the question about if we do something like that, it could be something that could affect the OSDs or RGW if it's RGW pools or whatever. Like there would have to be some smarts about everyone understanding like this is the pool I'm talking to and overriding those keys, but thinking about having a centralized place to manage it versus again one-off solutions in RBD.
The part that worries me is it's like a many-to-many relationship where there's not a clear mapping of an option to right now. Right now, the way that those options get expressed eventually funnel down to for any given daemon, you get a set of options, and you have one view of those options for that daemon. Whereas if it's pool and OSD has across multiple pools and whatever, and so it'd be different. Even an RBD client that like
no, exactly. It's
metadata is in one pool and the data is in another pool, and you have conflicting options coming in. Like, what that mean? I'm not sure it fits. We do have per image. There's already something that lets you set options per image, right?
Yeah, and the goal is to clean it up because right now it's kind of a hidden thing where you do like RBD image meta set conf underscore and then the name of like the config key. We want to have like a global unified config thing where you can see, for this image, here's the options that this image is getting and where is it getting that config from? Is it getting from an image level override, pool level override, or just a global configuration?
I guess we did do something weird with the manager modules where for each module, they have some of their own little config namespace.
Yeah, it's like MGR /
So we could have like config RBD / pool / option equals value or RBD / image / something.
Yeah.
Yeah.
I guess that the main difference is that in the case of the manager, those are a separate set of options, whereas in the case of I think the RBD stuff we're talking about, you're talking about options that already exist as part of the main schema, but setting them more specifically. So in the manager case, we skip the nice validation on things, but that's okay because they're not part of that main schema that's meant to be validated that way. Whereas for RBD, we would be creating kind of a backdoor way that people could circumvent the usual validation.
And to be honest, I'd still like to see that you'd use the RBD CLI because that's going to provide you the nicest interface, and, like see like where you're getting the specific overrides from. So even if the RBD CLI happens to be using Ceph config you're storing in the monitor for the override, that's fine. But from a user's point of view, they can just use the RBD CLI to interact with those overrides and not have to learn 3 different ways to change their configuration.
Yeah.
Like I said, I also wanted to clean up, as part of this, I wanted to clean up the way that you can do image level overrides so that you just have, hey, I'm specifically doing a configuration override. I'm not, setting a quote unquote image meta, whatever, with this magic prefix on it that makes it a config override for the image.
I think there are also slightly different users too. Like the Ceph config CLI is targeting the operator who's running the infrastructure, and the RBD CLI is targeting the user who's actually like provisioning storage resources. So I'd worry about mixing.
I don't want them to use. I don't want them using Ceph CLI.
Yeah.
Everything that's going to happen, it's going to be done under. It's going to be done under the hood. It's just a question of, do we build something ourselves? Like, I'm totally fine, happy doing the RBD/XYZ if we can whitelist it in the monitor, because right now it only whitelists. It allows you to do MGR/. If we could do RGW/XYZ, our tools can put all in, validate all the config options before it puts it there, yada yada yada. That's not a big concern. Or we can just store it in an object in the pool if it's not going to be used by anyone else.
So if the RBD tool is the only thing that's going to understand what goes in that prefix namespace, I would be inclined to say put it in the pool.
Yeah.
Okay, that was my original plan, and then we came up with all this monitor storing config stuff. And I was like, all right, should we use it or no?
Yeah. This is a bit of a tangent, but there's no reason why we can't have the monitor validating all those manager config options, right? We just need to make real schemas.
Right, it's just like,
yeah. Okay.
You're gonna keep it in the pool then? This is an RBD specific thing. We'll store it in an object in the pool. Okay.
I think that makes sense. Yeah, and it might be that when you do that, you want to like narrow the set of options that you're allowed to set that way. Like we already narrow the options.
Like
a whitelist
that config option. Cool. We don't like just set like mon, interval.
Yeah, exactly. Yeah. Okay, good. Okay, cool. Okay.
All right, that's really all I had to talk about.
Cool. Okay. Best subvolumes. Go ahead, John.
Sure. So the short version of this is maybe it's time we move Ceph Volume Client into a Ceph Manager module. The motivation being that we have an increasing number of things that want to use that functionality. Originally, it was pretty much just Manila. And then some Kubernetes provisioners started using Ceph Volume Client, and then sort of copy and pasting parts of it because they didn't quite like the way it worked. And now we've got similar functionality, I think, getting re-implemented in Go in maybe 1 or 2 places. So if we pull all that stuff up into Ceph Manager and just expose it as commands, then we can hopefully avert this sort of fragmentation. And at the same time, make it cooler and more capable as well. So at the moment, Ceph Volume Client only understands how to create volumes within a file system where they are essentially just directories. And if somebody wants to create a full-on file system that has a separate MDS and everything, they have to go use a different interface to do that. So I think it would be really neat if we could unify that experience in a Ceph command line, so that whether it's a lightweight volume or a heavyweight volume, just becomes a flag that people can use. That didn't used to be that useful of an idea because people would have still had to like spin up new MDS daemons and choose their PG nuns and that kind of thing. But now we're getting into environments where we can automatically create MDSs with the orchestrator interface and get the PG nums auto-adjusted. So we can put this friendly veneer on file system creation to make the whole thing much more dynamic, and then just also get a better user experience because it can integrate with the progress module to show you what's going on and that kind of thing, rather than what we currently have in Ceph volume client, where if somebody calls the purge function on volume, they just have to wait for that, and whatever is calling the code has to be smart enough to understand when it's doing a long-running operation. Not so. Hopefully, none of that's particularly controversial, I think. But the questions I have at the moment are: is it good enough to have commands for this that are accessible either via libRados or the Ceph CLI, or do we need to go as far as having a REST interface to it? I think REST sometimes seems like a no-brainer, right up until the point that you have to think about authentication, and you realize that you have to start doing all this certificate distribution. Anybody have any thoughts on that?
The idea. That's something we kind of wanted to do with the cluster Ganesha work anyway. So
Yeah. Yeah, I mean, on the REST side, it seems like as soon as we have sort of a clear path forward, we would just plop this into either the current RESTful module or the dashboard's REST API. But either way, it's just going to pass through the same code, right?
Right, you would call through into this module.
Yeah. I would start with the Ceph CLI, and then we can just sort of wire it up however else we need to do it later.
is there a way to have Manila call the Ceph command line in order to create the shares, or does it have to go through REST API?
So they can use libRados to send any commands they want, and that includes like commands that go to manager modules. It all goes through the same route. But I was thinking to make it a little easier on the OpenStack people, we could give them an updated Ceph volume client that just does that under the hood. So when they called into that, it would just be sending a command to the manager instead of having that code in line. I'm assuming that there are sufficient numbers of like Manila users in the field that might want to upgrade their Ceph before they upgrade their Manila. That would be worthwhile.
Yeah.
Sounds good.
And then my other question marks were what other plans there were around multi-file system and having file systems share data pools for Nautilus. Are we expecting multi-file systems to lose the experimental flag, Patrick?
Right now, we don't have anyone actively working on that, so an open question.
The testing gap, right? We just
assume
need test cases to do it.
No, not just testing. There were several to-do items as far as sharing data pools with multi-file system. I think you pitched the idea that we might declare it stable, but only with separate data pools, and that's certainly possible.
The auth caps as well. Especially for this use case, we'd want to make sure we had the ability to have clients that could only have the caps for a particular file system. I think we don't have at the moment, or maybe we do. As you can tell, I haven't quite done my research on this.
Can't remember. I guess this feels to me like it's orthogonal to the data pool sharing, though. Like that just makes volumes more efficient when they're actually deployed or whatever. But the abstraction that the user sees should be the same, I think, either way.
Well, I guess it's just a matter of scale. So if we want to declare it stable to have a few different file systems on the order of less than 10, then sure, it's stable. But if the operator wants to have hundreds or thousands of that file systems, then that's not going to be a good idea.
I mean, that's already going to be not a good idea because you have to have hundreds or thousands of MDS servers in that case, right?
Well, arguably, creating more MDSs is cheaper than creating more pools,
Yeah.
especially in a containerized setup.
Yeah, I was kind of assuming that people would want to share data pools for manageability um, for manageability reasons. But once you have dynamic adjustment of PG nums, then it's not actually that big of a problem to have like 1,000 little data pools.
Yeah.
It's just that I don't know, it seems kind of unnecessary if we could just, do a little bit of configuration work to have the volumes share a pool instead. I'm slightly fuzzy on in which cases we would tell someone to do it one way versus the other way.
It feels to me like it's only if you have like really small file systems that one PG is too many, because you could just have a one PG data pool and a one PG metadata pool. You just don't get the parallelism, I guess, for a tiny file system. But yeah, I don't know. It feels to me like the MDSs are the bigger issue. But I guess this kind of comes down to this, for me, this comes down to the volume, subvolume file system terminology and what they mean. It feels like we just have to be really clear about what that is. So we need to pick a name that communicates that the heavyweight thing is actually heavyweight. It has its own independent metadata server, and it's more about you pay more in resources, but you get more, fault domain isolation, I guess, out of it.
The more I look at this, the more I find the term file system kind of inconvenient for that, because I mean, what we give people in a subvolume when they mount it on the client side, I mean, that's a file system. It's just not what we call a file system on the server side.
Yeah. I think I would lean towards converging on volume and subvolume, with file system being sort of an optional alias, legacy alias for volume. Because we used to use, because right now Ceph FS new is a new, or Ceph FS LS or whatever to list the file systems. Those are really, I think that's right? Those are really volumes.
As far as the caps are concerned, John, I think that's been resolved now.
Awesome.
Pretty easy to just give clients access to all the data pools for a given file system. You don't have to list the data pools. I think that was the issue you were referring to. There is one.
I was also thinking about limiting their access to the MDSs.
Yeah, I think you also had an issue open for only distributing the MDS map that the client should be able to see. That one hasn't been worked on yet.
Okay, so I think the status quo is that the clients can potentially talk to any MDS for any file system at the moment, which it's only an issue if you've got a malicious client, but that's security for you.
Yeah. Another idea I had, Sage, regarding needing one MDS at least for every file system you want to create, was to have a rank for each, or have a MDS daemon able to have multiple ranks, and then you could have one daemon work on multiple file systems concurrently. But that's hasn't been fleshed out very much, and there's a lot of things.
So it would like bind to multiple ports. It would have multiple instances of the MDS rank thing or whatever in it. Makes sense. Yeah. Then you could have a single cache pool or whatever that they're competing for, something like that.
Yeah.
And you could even like dynamically, like if it crashes, the ranks could like move to other daemons or something. Or I don't know. Yeah. I guess that's sort of orthogonal thing also. Okay. It feels to me like those are sort of future optimizations that we can do to like reduce our resource consumption, but that the high level abstractions or whatever that we should settle on are heavyweight volume, lightweight subvolume. And in heavyweight in exactly which ways will change over time, and lightweight in exactly which ways will probably not evolve over time.
Yeah. So in terms of actually doing this stuff, I will probably go ahead and work on the sort of initial version of this, especially the heavyweight volume creation, because I want it for demonstrating the orchestrator stuff. I want my magic one command line operation that starts the NBS, creates the file system, creates the pools. That's my demo for Mount Point.
And I think the other piece of this is that right now we want to line up the CRDs that Rook is defining with these. So right now I think there's a file system CRD that is the same as the volume. So we should probably like rename it, I guess. But we also want to create a subvolume CRD and make sure that the dynamic provisioner for Kubernetes is creating subvolumes. Because those are the lightweight things that are going to come and go with high frequency and low latency.
Right.
Volume is the container that they live in. Yeah. Yeah. I would put that also as one of the sort of the high priority items, although hopefully we can get some help with that. So you're not on the hook for all of this, John. And I would think that the dashboard should expose all of this, right? I mean, dashboard already exposes the file systems volumes, right? But once the subvolume logic lives in the manager, then it could expose subvolumes too.
Yeah, I instinctively want to do that as well. Although if somebody is using something like Manila and they've got, tens of thousands of little subvolumes, I'm not sure how useful it actually is it's a little bit like with RBD images that if you're the admin and you're looking at the dashboard for your Ceph cluster and you don't necessarily want to like browse the RBD images that your users created with Cinder.
Yeah, it's probably not At the same time, like we do that, right? The dashboard does let you show RBD pools and RBD images and like delete RBD images and stuff like that. Yeah. So put in the same category as hopefully something that you're not doing, but probably in sort of more traditional environments where you have like a storage IT person who has a ticket open to like create a subvolume for some user, like that's what they would do. Maybe they would create a one in a more traditional environment.
Yeah, in both cases, I think it's really cool to have it in the user interface because it lets people sort of click around and understand their system. I'm just not sure how high priority it is.
Yeah, you can let the dashboard team prioritize it maybe. I guess my P1 is first sort of document and canonicalize what the terms are, and I would sorry, I lean towards moving away from the file system term because it's ambiguous and it doesn't have a space in it, and that drives people nuts, to volume, and have the subvolume have this sort of defined meaning that was previously sort of only Ceph volume client scope, and then have a standard CLI experience that sort of reflects that. So I guess that's what you're talking about, because when you do like Ceph volume new, it would just go and create daemons and data pools for you. Is that the idea?
Right.
Okay.
Yeah, well, we have to work out whether to call it. This is probably overly detailed, but whether to actually call those commands like Ceph volume new or Ceph FS volume new.
Yeah.
I don't know if Ceph can like commandeer the top level volume term.
Yeah, I would keep it Ceph FS so we know we're talking about POSIX volumes and not block volumes or something. Otherwise it'd be ambiguous. Volume is one of those like super overloaded term, so we have to be a little bit
Yeah.
careful.
It just means thing.
Yeah. Thing with stuff in it. Yep. Okay. And then yeah, the rook thing is like the next one, because we need to make sure that is doing the right thing sooner rather than later, I think. So as far as aligning all this with NFS, does enabling a Ganesha whatever, is that just like Ceph FS subvolume NFS enable or something like that? And then poof, it's going to go create NFS daemons and whatever.
So if you've already got the NFS servers set up and they're already one of these like groups that we're defining for the NFS daemons, I guess it's a case of associating a CephFS subvolume with one of those groups. Is that right, Patrick?
The ideal situation is that the manager actually spawns a new NFS daemon, probably through Rook, and then associates it with a particular share that it creates for a subvolume.
Okay. Are we still thinking? Sorry.
I was just trying to figure out if the NFS servers, are they mapped to volumes or subvolumes, or either?
Either.
Okay.
So the large volume is just the file system, right? That's what we were going with.
Yeah.
And then the subvolume is just a directory within that file system.
Yeah.
I suppose it could be either. The tricky bit is when you have multiple subvolumes, then the Ganeshas need to coordinate their grace periods. And if you have multiple Ganeshas for a single volume, then you need to do that as well.
It's only an issue if you have any inodes that cross from subvolume to subvolume. So if you got hard links across them, you kind of have to have coordinated grace periods, because we can't enforce that someone won't be accessing it over both volumes, right? Over both subvolumes. So we have to enforce the grace period there across multiple servers.
I forget. Did we add something into CephFS to like have a barrier to prevent hard links across the boundary?
Accidental one through the use of quotas.
Okay. Perfect. We're done.
But if you have multiple Ganeshas exporting the same subvolume, then they need to coordinate their grace periods, and that's something we want when we scale out and have multiple actives.
Right. Exactly. Yeah.
The other thing that I was wondering about the subvolume thing is subvolume client and Manila like create the subvolumes in a very specific way. It's a directory, I think in the root or in a /Manila or something that's named with the UID or whatever the name of the subvolume is. Do we want to like just pick an arbitrary and fixed way that those subvolumes appear in the parent file system volume, or do we want to make it more flexible so that it could be like /subvolume /whatever or /home/user or some other thing, so that a subvolume can be sort of an arbitrary path within the parent volume?
My instinct is no, partly to keep the clean upgrade path from Ceph volume client, but also just so that people don't sort of abuse this as a way of having individual mounts of whatever subdirectory within their file system that they want, right? Because if they want to do that, they totally can already. The point of the subvolume concept is that it's packaged up, shrink wrapped, and our commands and management tools understand how it's going to work. I mean, the exception I would make maybe is if they wanted to have an arbitrary prefix to all of their subvolumes within a particular volume, because they had an existing file system and they wanted to use a particular place to carve that out, then I guess I'd be okay with that.
Yeah, I guess that was think that was what I was getting.
If you're going there, then does it make sense to do something, have a directory hierarchy where you have some sort of top level directory and you stick all the subvolumes in there? So you have to walk down 2 components, but it might make it cleaner if you have rather than dumping a bunch of directories in the root.
Yeah, exactly. Yeah.
I think all this comes down to what do you want it to look like?
Yeah.
Yeah, and what sort of legacy stuff we have to deal with.
I mean, if we're just worried about the legacy, then we could make the volume client specify that the prefix is manila / or whatever it is there, and that's the backwards compatibility. And so that the argument, I get the argument that this is a shrink wrapped thing, and we don't want to like have people using it when they shouldn't. But at the same time, I think that argument goes both ways. Like we've already done all the work of making sure that setting quota and setting all the caps, all that stuff is coordinated and done correctly. And so why wouldn't you use this to, export foobar baz and have all that stuff set up correctly?
I guess because if somebody's using their file system that way, it seems to increase the chance that they would like go and delete that directory themselves behind the scenes, and we would. But then actually no, because our single point of truth, we don't have like a separate list of volumes, right? If we list the volumes, we go and list the file system, so it's actually not a problem necessarily for them to go and do that stuff. And, I guess as long as we're using the file system itself as the authoritative record of what volumes exist and where they are, then
okay. Well, if that's the case, then that kind of forces us into the mode where there's a single prefix and all the subvolumes live there, because that's the directory where the subvolumes are defined. Which seems like a fine compromise to me.
Right.
But then there's just a single per file system property that specifies what that prefix is for the sublines.
Yeah, that makes sense to me.
Okay. So then there's another variant of this where you could have like a collection of subvolumes that are in manila and another collection of subvolumes that are in /foo. Those are just 2 totally independent subvolume collections, and then like the user who's using this specifies which of those subvolume collections they want to use or care about or something. Is that useful, or should we just make a per file system property that's like in the MDS map or something, like a file system metadata field that defaults to like /subvolumes or something?
I think it's gonna be pretty common for users, like at home who want to export maybe a home directory over NFS. They're going to want to be able to just give an arbitrary directory, and that's something we should probably want to support.
But we don't have to call that directory a subvolume, right? Like it could just be that the NFS functionality can either export a subvolume or an arbitrary path.
Yep. On the other hand, maybe you have home directories and you want all the same things that subvolume offers, right? You want quotas on per user basis, and you want different caps, and you want to restrict them into different namespaces. Like maybe you want to do all those things.
Yeah, you can definitely think of use cases where you would want it to be more flexible than I'm suggesting. One way to do that perhaps would be to have subvolume like links. So we would have like one directory in a file system that has all the subvolumes in it, but you could have dummy ones that were just a pointer to another path, so that all of our like housekeeping stuff and our ability to enumerate subvolumes only had to deal with one directory. But you could totally have a subvolume that in reality was somewhere else in the file system, maybe.
Yeah. Maybe coming at this from the other direction, we should make sure that the functionality we build to like add an NFS export is not strictly tied to a sublime. So you can still export rhubarb as and use all the stuff that spins up Ganeshas or whatever, even if that's just a directory, some random location.
Yeah.
It doesn't really help us simplify anything. But well, maybe the way to proceed is to start writing the code assuming a fixed path for sublimes in a file system, but be thinking in the back of your mind how big a role that fixed path actually takes and if it would make sense to, if there are opportunities to extend it or not based on how complex the implementation actually is.
Yeah. I mean, I think what you said a second ago about having a prefix in the file system map per file system makes the most sense to me as a starting point. But you can obviously see how if we ever did decide we wanted to have like more than one of them per file system, we could extend it later. And I think the idea of having links into subvolumes satisfies the use case of the person that has existing directories that they want to start treating as subvolumes.
Yeah, that might. It's just a symlink, basically.
Yeah.
Yeah. Yep. And it avoids having this like 3-level thing where you have volumes, subvolume collections, and subvolumes, which is probably annoying.
Well, there is one extra layer that I haven't mentioned, which is that because it was to support Manila, the current volume concept has volume groups, which are like snapshot groups. So those
right.
need to live on as well.
Yeah.
There, 9 times out of 10, there's a one-to-one relationship between the group and the volume.
Yeah. And the volume group is where the quota is set and the owner restrictions are set, or what's the purpose of? It's just scope of snapshots. That all?
Yeah, it's just that you can snapshot them together. So when you actually mount them, you mount just individual volumes, not the group.
Okay.
But if you want to be able to coherently snapshot several volumes together, which is something that Manila offers, just like Cinder does, then that's what the group is for.
Okay. Are we going to make that also apply everywhere, or is it going to be an optional thing?
You mean, do I want to expose the groups to anything but Manila?
Yeah. Like if you do Ceph FS subvolume create, is it going to implicitly create a group with exactly that one member? Yeah. Okay. That'll be a uniform structure, I guess, on disk.
Yeah, that's how it works at the moment in subvolume client.
Okay. Yeah, because Kubernetes has no concept of group, but it doesn't hurt. It's just one more layer of directories. Okay. All right. Anything else on that?
No, I'm good.
All right. All right, and then the last topic was Ceph's MDS workload profiling. This came up in a discussion about trying to understand a customer workload, and Uday talking about how back when he worked for whoever, They all these great tools that you could just turn on in a production system and it would capture a magic file that would tell you everything you wanted to know. It's kind of a hard problem though, so I just wanted to throw out a few ideas. I don't know that I have any like specific proposal or good solution. One way to approach it is through just more and better metrics. So the idea would be to expand the perf counters or whatever it is to make sure that we're capturing all the different code paths that the MDS is taking, how many misses it's having on directories, how often it has to load versus not load, when it does load, how big are the directories, how big are the directories when we do lookup, all that. Try to sort of quantify all that stuff, probably in the form of perf counters. That would be one piece of it. There are also some ideas around improving the same sort of instrumentation on the clients. So Patrick suggested making the caps, the clients keep statistics on the caps as they're used on the client side, and whenever it passes that, the cap relinquishes the cap or updates it or flushes it back to the MDS, it passes those stats along so we can tell how many hits are happening in the client, sort of lazily as they get flushed. And then probably some tooling around like capturing these metrics so that in some canonical form or something or other, and then you could go off on a whole tangent there. I think the end result of that type of approach is that you have this like sort of quantitative characterization of the workload, not directly the workload, but what the MDS and the client are actually doing in response to the workload. The problem is that doesn't actually let you reproduce it. You have to like go and generate a workload and then look at its resulting profile and try to adjust it in order to match the one that you're trying to reproduce. And assuming you could like turn enough knobs on your synthetic workload to match the same profile as what you're trying to reproduce, then you have something that's similar enough to do it, which is sort of the secondary weird piece that seems hard. Maybe you could automate some of that, like if you have, I don't know, you could probably like train a neural net to do it, or I don't know, whatever. You could do something. But it's sort of this like two-phase process, so it's not entirely satisfying. But it at least tells you what's going on, so it might be worth doing. That would be one way to approach the problem. The other way to approach the problem would be to just capture traces. We could capture traces at the MDS, but they're hard to replay at the MDS because you really need to create a client workload that's above the client. So I'm not sure how useful MDS trace really is except for debugging. Or you could try to capture traces at the client. That's probably pretty doable for the for the user space client for Ceph use. In fact, there's a bunch of tracing stuff in there already that's probably totally broken, but I used way back when just doing the initial Ceph paper. Capturing a similar trace for the kernel client is probably a totally independent approach to how we want to implement it, though. So I'm not sure that much whether that makes sense. The nice thing about a trace is that you can replay the trace. Kind of traces in general are hard to replay because you also need the data set that goes with them, and when do they start, when do they end, and how do you set everything up. So that only kind of helps. So it might be that even with traces, you still have this sort of second phase where you have to like do a bunch of work in order to actually make it into a useful workload that you can reproduce. The last thing I wanted to throw out was a link to this paper. We used to talk about this a fair bit. This was actually on a block layer trace. So this paper, this is the thesis that went with the author of the paper. There's a shorter paper where they basically did this, but they basically took traces of workloads on a block device and they did a bunch of quantitative analysis of it to figure out how random was the workload and how much did it jump around and how many concurrent IOs, all this stuff to like model it. And then they had a conceptual model, and then they expressed that model as a file bench configuration file. I think it was file bench, one of those tools, so that you could actually run a synthetic workload generator that had all the same quantitative characteristics as the original workload. And then they showed that it had this similar performance on the system, basically, which is kind of like the magic that for the first part, if we started with metrics and we just characterized the workload, that would be the magic piece that would then give you a synthetic workload to reproduce the workload, except that it was done with a block device, which is like super simple space for a workload compared to a file system where you have files and directories and lookups and renames and opens and closes and reads and writes and like all kinds of random crap. So I think doing the same thing for a file system workload would be much harder, but maybe doable. I think it kind of depends on what metrics we would capture. So that's the brain dump. What do you guys think? Is any of that?
I think the general case of that is ridiculously hard, but there are some pretty nice bits that we could do, like getting the file size histogram, getting the directory size histogram, getting the trace of like the last 1,000 ops per client session, especially what type of op they were. I've sometimes thought about using that trace of operations to classify clients, partly just for display to the user, but also maybe to change the cache mode on the MDS. So like if you identify somebody that's doing just sequential creates of files and never touching those files again in the short term, then you can start throwing them out of cache immediately after you create them. And I think there's at least a few cases where you can pretty easily identify the workload. Like you can identify something that looks like an untar. You can identify something that looks like an ls-l, pretty much just by looking at the last 1,000 ops. And if they're all stats on different files, that's an ls-l. If they're all creates and it never touches anything again, then it's probably an untar. But even that kind of simple stuff, I think, would be pretty useful if you're looking at your top 10 clients and, who's this guy hammering my system? Oh, he seems to be doing a file create workload. And of course, if you identify something like the LSL case, you can think about doing read ahead metadata.
Mm.
This is kind of a different thing from what you were talking about in terms of the purpose.
Yeah, but I think but interesting nonetheless. I wonder they align. Yes. I mean, you're thinking of like changing the behavior of the online system in order to better deal with the workload. And I'm just trying to figure out how to reproduce a workload.
Right.
And data set in general.
We already have enough data in the system to get the histogram of OSD write sizes. So, I mean, that would be one thing that we could gather today for workload generators that can generate the same distribution of IOs to the OSDs in the background to whatever the metadata workload is.
Yeah. And for the purposes of Ceph, we could even ignore all the IO and just focus on the metadata workload. I mean, if we just were to like think about what is the like simplest, vaguely complete model of like a metadata workload, it's like with file size histogram, although the file size might not matter too much. Directory size histogram would be one. Directory like branching factor, like average and standard deviation of how much directories are, how deep the hierarchy is. Like distribution of cross directory hierarchy, like how deep are they?
I don't think the directory depth would matter too much. You would just really care what's the ratio of the directories to inodes. If it's 1-to-1, you got mostly directories, where you have entirely directories in cache. Do we really care about how deep the hierarchy is? I mean, you could have a really broad tree and then a really deep tree. Does it really matter?
I think I'm thinking that if you understand, if you're trying to characterize a workload and you understand how much the workload stays in a directory versus accesses things up or down the tree from that sort of starting point, then that would let you reproduce that workload sort of independent of the cache size. So then you could scale up the cache size and then know whether it's going to perform better or worse. Because I'm kind of assuming that the thing that's going to slow these workloads down is not everything's in cache, and so you're going off and paging directories in and out, or directories become incomplete or whatever. And so being able to characterize the factors that make that happen or not happen.
Yeah, so you look at like the last 1,000 operations, and for each one you record what type of op it was, whether it was in a different directory than the last operation, and probably also was it touching a file that had already been touched in the last 1,000 ops or something like that, so that you could distinguish between things which are operating repeatedly on the same files versus things which are operating on different files.
Yeah, you'd want like a reuse histogram or something like that.
And the replay logic would just, generate a random number and use that to decide whether to access something in the same directory he's currently in or in a different directory.
I mean, maybe this is even like too ambitious. Like workloads are either going to like scribble a bunch in one directory, or they're going to like write once and move on, or maybe it's, I don't know. I'm just thinking from the perspective of if we wanted to capture a bunch of metrics on a workload, and so the analogy of the block case, and then have something that would like both generate a data set and generate a workload that like had the same impact on the cache. What would that take? It seems like you need to have it seems like it has to be a reasonably sophisticated model that accounts for like what the directory structure looks like and how you move around in the directories and what your reuse behavior is. But I don't maybe this is like, is this too big of a leap also? Like, should we just start with the basics?
Yeah, I think we should just start with the profiling.
Yeah. I still want the automated test that sits there doing asyncs. I think that so many of the workloads that we see in the field will boil down to one of these short lists of things, right? We should make sure that we actually have taken these obvious things and measured them and reproduced them before we worry about these.
An arbitrary thing.
Yeah. Although this is more fun.
Yeah. Trying to think about what's the deliverable? Like, what's the actual thing to do?
Have you considered looking at something like dbench? Which does something quite similar to what you're trying to do. Maybe you could. I wonder if we could just extend it.
Yeah, I mean, we run tools like dbench as part of the stress test suite. Ben England created this small file tool that uses multiple nodes and generates lots of small file workloads and is parameterized in like 12 different ways to try to reproduce these workloads. I think the thing is like, how do we know that the workload that we're generating is related at all to what a customer is doing?
Well, I think you have to be able to record their activity.
Yeah.
And I think that if you use something like LGTNG, maybe you could capture that to like a Babel trace, which is pretty lightweight, and then turn right around and build some program that converts that into some sort of like dbench like program file, load file.
Yeah. I mean, that's kind of that was the idea, right? You capture a bunch of metrics. Or trace.
You got to do the capture part, and then once you've got the ability to capture a workload, you got to be able to convert it to something useful.
Yeah.
Or some things useful. have you considered the first part yet? I mean, what are you going to use to record a workload?
Right. So those were sort of the two high level buckets. Was one is metrics, where we're just measuring like when we're taking certain code paths in the MDS, like how often we miss the cache, or how often we have to read a directory off disk, or how often we process a stat, or whatever it is. And you get a bunch of metrics and histograms or whatever that quantitatively describe what happened. And the other approach would be just to capture a trace. And then you have to do some analysis to either get similar information or.
Okay, now I get it. So you want to be able to capture some sort of like long-term statistics and use that to generate a workload. Yeah. That might be hard. I mean, I'm not sure how useful that is. Do you? Yeah. If you're capturing over a whole day, I mean, the load can spike significantly, and then it's really hard to capture that in the instance. So maybe there is some way to do it. I don't know. I guess you said that was the paper that guy wrote.
That was the paper that I did just for block volumes. But it's pretty cool. But I mean, the high level idea is basically like you have a production system and you have somebody turn it on for a little bit and they gather some data, hopefully with minimal overhead, and then they send it back to you. And that gives you enough information to like reproduce something that's similar. You can just synthetically generate a similar workload.
Yeah, so I mean, maybe some TNG trace points right in the midst of where you dispatch into different MDS functions.
Yeah.
And then you collect all the info that you need for those, to be able to simulate the workload afterward.
Yeah.
A little heavyweight, but I mean, if you're turning it on, you expect to take some performance impact. And LGTNG is about as light as anything you're going to get. So you maybe do that with that would be pretty simple, I think, in principle.
But then how do we turn that back into a synthetic workload?
Right. Then you have the Babel traces, and you have to write a converter program that can turn that either into a synthetic workload, in whatever fashion you want, right? You've got the traces for it. Now, collecting statistics is a little different, though. That's the other piece, and you have to be able to have some sort of that I don't know how to do.
You'd still have the thing that kept that state of what does my tree look like and what were my last n operations like. It's just it would be doing that as it went over the trace output rather than doing it within the MDS.
Mm-hmm.
Yeah, though I don't know that you need to record all that stuff you're doing, for long-term statistics, if that's what you're talking about doing, right? For that, you don't want to collect as much info over time in general, I think. Running LTTNG for 10 minutes is fine, right? But running it for full time you're going to notice some performance impact from that.
So at the risk of distracting from that core idea about reproducing workloads, another reason I was thinking about this before was for file system replication. So if you could have a heuristic for different subtrees that could tell, is this a subtree that's doing just lots of file creates, or is this a subtree where people are working on modifications within big files, that might cue a replication agent to either wait for the untar to be finished and then do it in one go, or if people are editing files a lot, then it might need to use a snapshot-based method to copy from one cluster to the other. That's a little bit more out there. It was just a related thing that I had been thinking about.
So, I mean, putting trace points all over the MDS and all the relevant code paths, you could emit trace events, or you could just add a bunch of counters there. You obviously get less information with the counters because you don't have all the timing and so on. I think that the key question is it possible to have a lighter weight than a trace approach that's counter-based that captures sort of the reuse dimension of the workload? How often you're going back and looking at the same file in the same directory within a short period of time. type of thing.
Yeah, I think you kind of need both, right? I mean, you need the ability to turn on the more heavyweight tracing to replicate a specific workload, but you probably also need the ability to collect statistics over time and do something with that. I don't know what kind of stats you need, but
I guess what I'm the train of thought here is that if there isn't a counter-based approach that's going to sort of capture that part of the information, and we think that's important in reproducing the workload, that you're going back and looking at the same files in the same directory again in a short time window, then maybe we just focus on the tracing part and don't sort of try to do the counter approach. I think so. The other nice thing about the trace approach is that it's more open-ended. So if we implement something that will capture a hopefully somewhat meaningful trace of workload, you could do some post-processing of that now and have some like low-level insights, but you could always come back later with a more sophisticated analysis, learn more from it. Whereas the metrics sort of like box you into exactly what you're going to learn.
yeah, and it's more than that. I mean, I think it's just as a project, it's more straightforward to envision, right?
Yeah.
You can pretty straightforward to put in trace points and then turn that into some sort of load file. But doing something heuristically is a little more out there and tougher to do. And you might need the evidence from some traces to be able to figure out how you want to do this. I'm not going to figure on that bit of it,
Okay. So then I think the next question is there a viable path that generates a trace from the MDS that has enough information that sort of infers what's happening at the client? Or do we need to do this at the client? And is actually tracing like, the 1,000 clients in the system, or maybe just a subset of them, is that a viable practical? Is that going to be practical in a real environment, given that you have a mix of fuse and crawl clients and whatever else?
And there's dispatch client request in the MDS server.
Yeah.
I mean, you could just go plug them into there.
Yeah, that just misses all the client side activity that hits the client cache.
Oh, right, yeah. I didn't think about that bit. Okay, yeah, you probably need to do it on the client actually.
Or you'd have to have some hybrid approach where the client is counting how often it uses its caps. Like if you have the cap in metadata that we're talking about, where you know how much the caps are used on the client when they get flushed, and you're logging that in the trace, maybe the combination of those two things is enough, and still lets you do it just on a per MDS.
Okay, so you have perf counters that are covered by the caps as well, basically.
Kind of, yeah.
That might be the way to think about it.
Yeah.
A lot of this depends on what's the goal of collecting these workloads. Is it to reproduce behavior in the MDS or understand the performance of the system as a whole? And I think you only really need to collect trace information from the clients if you want to be able to replace something for the purposes of analyzing performance.
Yeah. But at the same time, like even if you only care about the performance of the MDS, you need to be able to generate a workload that's going to have the same workload on the MDS. I guess that's sort of the part of the problem.
Right, but if from the MDS's perspective, it doesn't matter if the client uses its caps or not.
Yeah, I guess so. Yeah.
Maybe consider starting with the MDS piece and then extend that to the client later.
Mm-hmm.
Tracing the MDS seems, I think it's a lot harder than we're currently envisioning, because you also need to capture the state of the cache, the LRU, and how the cache changes as you go through the workload. Things are getting evicted all the time when the cache is full.
Mm-hmm. Yeah, you say to have trace events for all of the actual client operations that happen, and all the like I/O that comes in and out, where you're loading a directory or dropping cache hits and cache misses. Yeah. Okay. Well, that's what I had. A whole lot of food for thought and no real answers. But um, hopefully that's moved our thinking on along a little bit. All right. Anything else that we should discuss?
If I may,
Mm-hmm.
I would like to leverage the fact we had a lot of RBD stuff today and add one small thing that came just around 1 hour ago, so it's very fresh.
Go right ahead. I'll be right back in a minute.
Sure. Let me provide some background. In OSD, we have a course lock. It's PG lock. Why? And it can be taken only exclusively. It's a mutex, not a read-write lock or something like that. We are also lacking asynchronous read functionality in OSD in our object stores. As a result, if we have multiple operations like reads that could be really can be make in parallel, but they are targeting the same PG. As a result, only one of them can be executed. Tried to address typical victim of such behavior is the small run-read sequential read scenario in sequential read over RBD image. We tried to address the problem turning on the PG lock into read write lock. However, we have plenty of organization primitives, plenty of organization behaviors in object stores that rely on the fact that pglock is a mutex. We also tried to go with asynchronous reads for each read we see in the system, and it helped sequential reads in RBD a lot. Benefit was even 2 times more IOPS or something like that. Unfortunately, we also hurt the performance of small round reads workloads. I wonder whether we could try to reiterate the problem, basically going with the asynchronous read approach, but in a more selective manner. That's the reason I would like to ask about possibilities to implement in RBD or in any other Rados client some kind of hints that can be consumed by an OSD. Something like this operation is sequential because it's read ahead or something like that. Do we have such possibility today?
There's definitely some kind of hinting somewhere in the stack. I'm struggling to remember exactly where it is.
Unfortunately, I'm unfamiliar with the read ahead implementation in librd. I know theoretically it might be possible. I'm just unaware about its real doability. I mean, the trade-off between benefits we could get for the costs we would need to pay to implement that feature.
I mean, there is in librados, it looks like there's a rados read ops set flags and write flags, set flags for write ops as well. Is that what you need, or do you need something more elaborate?
Oh, could you write the name? Oh, thanks.
Those. And the librados op flag fadvise.
Sounds really interesting. I was gripping for something like Retail Hat or similar. I missed this one. Thanks, guys.
No problem.
Well, it looks like we lost Sage. So we can all look at his collection of plants.
Yeah, I need to drop, so I'll talk to you guys later. Have a good one.
See you.
Okay, I'm going to. Thanks, everyone.
Bye all.